Welcome to the Overcommitted podcast, your weekly dose of real engineering conversations. I'm your host today, Erika, and I'm joined by...
Hey, I'm Brittany.
And hey, I'm Bethany. We met on a team working in GitHub and quickly realized we are all obsessed with getting better at what we do. So we decided to start this podcast to share what we've learned. We'll be talking about everything from leveling up your technical skills to navigating your professional development, all with the goal of creating a community where engineers can learn and connect. Today on Overcommitted, we are joined by Cameron Etezadi, the Chief Technology Officer at LaunchDarkly, a feature management platform used by more than a quarter of the Fortune 500. Before joining LaunchDarkly earlier this year, he spent years scaling engineering organizations at Google, HashiCorp, and SAP, including navigating Concur through its acquisition by SAP and later guiding HashiCorp through its acquisition by IBM. He studied chemical engineering and biochemistry at Rice University before moving to Seattle in the mid-90s to write software at Microsoft. And somewhere along the way, he also became a licensed flight instructor with ratings in fixed wing, seaplane, and helicopter, among other planes, I understand, and has logged over 400 skydives. Cameron, welcome to Overcommitted.
It's great to be here. Thanks for having me. I'm excited today.
Well, to kick us off, we'll ask you what we ask everyone on the show. What's something you are building or obsessed with learning right now?
I think I'm so excited. It's like science fiction's become real with the AI changes in the last year. And so it's like being a grand wizard in software just materializes. And I'm obsessed with figuring out how to issue the right incantations, put out the right spells so that what comes out is actually what you want. I have these visions of Mickey Mouse and Fantasia as a sorcerer's apprentice these days where the mops and the buckets start running away. So I'm obsessed with figuring out control systems and building efficiency into the process. Our corporate mission has always been about separating release from deploy and breaking the two things apart. And I think that's even more important right now as things have changed. So I'm literally geeking out every day on solving the problem and making it relevant in today's AI world.
Yeah, the problems haven't changed, but the tool set definitely has. Well, let's start there with coding with AI and the difference between vibe coding and writing software for production. And, there is this difference between code that compiles and code that actually works the way you intended. So can you unpack what that means to you and maybe give an example of when you've experienced code that looks like it does one thing and then doesn't quite do the same thing in production?
I've been in this industry for 30 years, and my favorite phrase from the early days was, "Hey, it worked on my machine." And I think we've all been there. You three are practicing engineers and probably know this well. And I think vibe coding kind of takes that to the next level, to be honest. It's very easy to produce code that works, especially down a happy path where you achieved your objective as long as everything is perfect in the way. It doesn't scale. It doesn't operate. It doesn't run at enterprise scale. You guys know from operational experience, day 2 is just as important as day 1 when you're putting out software for millions or hundreds of millions of end users. Vibe coding doesn't have that yet. And maybe it'll get there, but it makes architectural mistakes that no senior engineer would ever truly make. And they get better over time, but it's not capable yet of understanding the very nuanced things you need to do to run at scale. So coding has become free. That part of it, translating English into Python or Go or Rust, or pick your modern language you actually want to work in. Please don't say Java. COBOL. It does it really well, but it doesn't fix the rest of the process, the release, the operationalization, the monitoring, the metrics. There are pieces of that, but that still takes time and effort and cost. And so what we're really doing with the vibe coding is shifting the bottleneck in the process of software delivery to different points. And this is where the process just backs up somewhere else. I had said that, code that compiles is structurally correct, but it's often not functionally correct. Great example for us is we built a system internally, and it used AI. Even 60% now of our check-ins are are running with AI somewhere in the process overall, and 30% are just done without human touching it. It picked the wrong environment. It hard-coded in the code the test environment. And so all the tests pass. And when it went out to production, the data wasn't streaming into the database like it should have. So the output was wrong, and the test didn't pick it up because the test passed because in the test environment it worked. We would have, as experienced engineers, noted this when we were writing it and said, oh, this has to be a variable. This has to pick it up from the environment. This has to pick it up from Terraform, from config file, from somewhere. This code, hard-coded it and was fine. So it's a really good example of structurally the code was fine, but it didn't really actually work in practice. It was behaviorally incorrect.
Yeah. Yeah, that's interesting. I had something similar happen to me and I was debugging with AI assistants and, asked it why something wasn't rendering. And there were two layers. It was like there was a visual layer and then there was also like a server side filtering layer. And it fixed the visual layer, but the server side layer wasn't included in that. So it was kind of example to me of like, oh, it doesn't always do that second, third order check. Like it doesn't do this whole thought process of, okay, we're going to fix this thing. I fixed it. Now, how are we deploying it and making sure that it works in production?
I love, Erika, how you phrase that with the third order effect. As experienced engineers, we're trained to think about the consequences of our actions. The AI doesn't always think about the consequences of the actions.
Hmm. It's not on call, so,
Yeah, I got to share it because I love this. We've all heard about MTTR and MTBF and how our software stays up and how fast we fix it. And years ago, there was somebody who told me the metric I should really be watching is the meatball. MTBLOS, mean time between loss of sleep. How often you got to wake up in the middle of the night and fix your code, and that's how happy your team is. And the AI is never going to complain about losing sleep.
I like that one. I'm going to steal that.
Please do. Please do.
now I'm going to be dreaming about meatballs the next time I'm on call. Yeah. Yeah, I mean, the other thing that AI does not do is it doesn't hedge. It doesn't ever question itself. There's no like self-reflection. So in your mind, I guess when you're reviewing this code, you kind of touched on this with the example you gave, but for an engineer who's reviewing AI generated code, how does that change how we read this and how we involve ourselves in this software lifecycle? Like, what would you look for, I guess, when you're reviewing an AI generated PR?
Yeah, the structural correctness is there. Like it compiles, it runs. The best users of AI use it for goal seeking, which is start with the objective that you want. In a way, this is like the ultimate test-driven development like we did for a while. And I think it still behaves that way where you're writing to satisfy the output because AI is really at the fundamental level, like the technology is just a goal-seeking kind of path of gradient descent to your answer when it comes down to it. I'm looking for those second order effects, the what ifs, the what could go wrong, what could happen here. We can predict, poor API calls, badly formatted parameters, buffer overflows, cross-site request forgeries, all the stuff we've done for a while. But it's those second order effects to my business, to understanding my domain that it's not nearly as good at. And I'm worried about, I'm worried about three things. I'm worried about building good code because fundamentally I'm an engineer and I nerd out on building good code. Second thing I worry about though is building a healthy organization that's sustainable. And the third thing is I'm worried about building a healthy business because we're all in this to eat and survive and hopefully make a little money in the process.
I don't know how much code you're reviewing, but I guess theoretically, if you were in a situation where you're reviewing an AI generated PR, would you use AI to review it at all? Would you do it all manually? Like, what would kind of be your checklist?
I absolutely love LLM as a judge and those patterns of evals where you're using one agent against another. It turns out agents, as good as they are at writing code, for instance, they're really good at critiquing. It's easy. It's funny. I've spent some time like on the philosophical side thinking about this, which is we're really good at criticizing other people as humans. Like we love to poke holes in things, throw rocks. Turns out when you train a bunch of LLMs on human generated content, they pick up some characteristics. And so I've always felt like maybe they're a little human in that regard and I anthropomorphize them that way. So I like to use other models. I like to use different vendors, open source models, the freebie models. Quen is a good example. Kimi, Even DeepSeek is super cheap. Like using it to play adversarial roles and question things is really helpful. I've also come to the conclusion in the last, few months, the more I get it to engage and ask questions and play the what if, it becomes a good thinking partner. And so I feel like the best engineers in the organization are using it as a thinking partner and not trying to just one-shot something, but actually working through workflows where there's a really good set of research, a really good set of planning, and that process is iterative. It's like the rough drafts we all wrote for papers back in high school where you kind of help your thinking along by questioning your assumptions. And so that's what I like. I like to use agents to check agents, and they are good at it.
Bethany, Brittany, what about you with your production checklist when you're reviewing an AI generated PR? Has this changed for you at all, or is it kind of the same checks that you do for a human written PR?
Yeah, I think for me, it's helped in a way of I can zoom out because I don't have to just rely on the context I have in my brain. I can also say, hey, how does this impact the broader picture? Can you diagram out what this actually changes? So for just being a visual person, it has reduced the mental load of PRs a lot. Even though there are more PRs, I do think that having AI as an assistant does help a lot. It is so funny, though, that using different models will challenge more than using the same model. I don't know the science behind that, but I do find that very funny and very human in a way.
Yeah, I agree. I think that most AI now is probably as good as, an average engineer when it comes to, especially when it comes to looking at things. Like I feel like they pick up a lot of things that I might not necessarily pick up when I'm doing a review. So I would say that, any of the smaller like consistency sort of things, I typically say like, all right, I'm gonna let the AI handle that for now. And I'm gonna look at the larger picture. Like, does this solve the problem? Does this, is this like architecturally the solution that we want to continue supporting in the future? So I feel like even if something was written by AI, I definitely also use AI to review the AI with the robots pointing at the robots.
I think it's been really good. We found things. It's found things. It's pointed out bad algorithms. I had one the other day where it found a polynomial time algorithm in the code that the original code had and had had for a while. In fact, it was touching the function, and it pointed it out, and it got to the root of a problem that we were seeing in production where things API was great until we got a lot of use on that API, and then it started to fall apart because there was an n squared algorithm there, and nobody loves those. We should have caught that, but we didn't. But the AI did.
Yeah. So let's kind of talk about the feedback loop of the release cycle. And this kind of touches on everything that you mentioned. Like there's the code, there's the organizational aspect of it, there's the maintenance aspect of it. So, there's the release, there's the observation, there's the iteration. And in your mind, Cameron, what does this look like? What feedback loop look like when it's working well? And what's usually missing when it's not working well?
I think that loop is really important because if we learned anything in the last 25, almost 30 years from agile and extreme programming and all those sort of methodologies, it's all about small incremental changes to try to drive to the right answer. And if you take that for a philosophy that, I'll say this as an ex-Amazonian myself, like that Jeff Bezos had at the start, everything is supposed to be a two-way door if you can. Reversible changes, course corrections, and you spend your time on the one-way doors. There's lots of talk about that, but I think it holds true. I think it holds true with these agents. And so the natural extension of this is when it's very inexpensive to make a change because it's very easy to write the code or not write the code as the case may be. I think this ROI loop of release, observe, and iterate becomes ever more important. And we're trying to get things out to production at a pace that's unprecedented. So making those incremental changes, finding your product market fit or your improvement or your goal, and then being able to make small changes of 1 degree of freedom at a time is super critical. I think where it's missing is a couple of things. It's understanding what went wrong. So in agile development, for instance, for years, we said, one line changes or functions that only fit on a page so that a human can put it in the head. Well, the context windows for these agents are so much larger now. You can make bigger changes because you don't have to hold it in a human brain. You can hold it in an agent brain. But you still have to understand what you did and why you did it. So I think that understanding is often missing. The right set of observations is often missing. So what am I looking for here? What are the metrics I want to gather out of this bit of code? Is it latency, throughput? Or is it a business metric? If I were writing a payments gateway, how many people did I steer toward Visa versus MasterCard? Right? That's also really interesting. Did this change my conversion? So you're almost having to set up an experiment, and I'm a big fan of experimentalism. Right? I think people don't set up those experiments correctly for the right output, and then gather the right data to make the right decisions, and then closing that loop very quickly, knowing where either a feature flag, which we can put in there to steer an A/B test or to run a multi-arm bandit or any type of those type of experiments that you would run, like those aren't in place either. And so it's really a matter of learning where your control points are, learning how to know what the control point data means, not just that you're getting data, but what does that data mean? And then being able to act on it. And so I think there are gaps there. We're all just trying to get our job done, which we used to think of was get the code to production, just write code, right? And our job has changed to build an experiment, understand what you're doing, move fast, and try not to break things.
Yeah, I mean, in some cases, it's better to not ship the code, right? And yeah, there's always got to be that question, what happens if I don't do this? Yeah, in addition to what is better if I do?
I've changed my opinion a lot in the last year. I'll use another Amazon thing that sticks in my head. I mean, I was a baby engineer, early. I think I joined Amazon at 32. So I had a little bit of experience, but definitely not a lot. And, the two pizza team concept, I'm sure we've all heard of it. We've all found a squad of, 5 to 10 people that you could feed with two pizzas. I think that those days are over. I actually think I'm now a believer in the 2-slice team method, where somebody who can feed himself or herself for lunch on 2 slices of pizza and controls a team of 4 agent teams underneath them has sort of replaced that engineering 2-pizza team. But that means the behavior of an engineer has changed from I'm an IC to I'm a frontline manager. And so you have to behave on project management, on work breakdown like a frontline manager to be successful now. And that's changed the pace of everything. The only good part of an IC being a frontline manager is you don't have to have any of the emotional intelligence that we need to manage people, because the agents are going to tell you you're beautiful, you're smart, and you're the best person in the universe all day long while you're doing the work.
So how does someone learn those skills or build those skills going from an IC to, taking on more of the manager position?
I think we're looking for a different set of characteristics. And this is all personal belief right now. I'm still hiring interns to be clear. I don't think the answer is hire only senior engineers, which some companies have chosen to do. I think that's actually a mistake, personally. I think you build the skills because you look for folks with leadership experience who have led in other ways, led organizations, led projects, even big projects, whether it's in college or in a social organization or in other companies. And I think you look for folks that have systems thinking behaviors. So we've gone through a lot of different thinking patterns, but the folks who can think holistically with a systems thinking approach tend to do much better at this. Also, folks that thrive in chaos, who can bring order to chaos, because there's a recent study, I think it was HBR, Harvard Business Review, a few months ago, that said 4 agent teams or 4 tasks is really sort of the amount that you can keep in your head and be more and more productive until you hit that point. And then productivity through context switching just drops off rapidly. And so you need folks who can deal with that context switching all day long as well. And I think if you have that, project management can be taught. Good engineering can be taught through experience. And I think you can develop the rest of the characteristics. For my entire career, fully believe that computer scientists and software engineers are 2 different things. And you always see this in a new hire. You all, I'm sure, have hired people onto your teams, new college graduates. We were once new college graduates ourselves. You come in with great computer science knowledge, write an algorithm, understand a programming language, but you were probably a terrible software engineer at that point in time. And it's not anything personal. I was too. So I did not. I don't even have a computer science degree. So I was just bad at everything. And somehow I got hired. But you come in the door and you spend that first year on your team learning what it is to work through a bug workflow, how to release software, how to make the right engineering trade-offs of, oh, this doesn't have to be fast if it's simple and I can read it, or boy, I really need to focus on this section of the code. Those behaviors are there, but they're just price of entry. And the rest of the skills that go with that systems thinking approach are the things that we need to now hire for and be looking for.
It's so interesting because we were actually just talking about this in a previous episode, but it's funny that it seems like interviews still seek that computer science skills through the algorithms questions and data structures questions and stuff. So it's so interesting that even though the actual desired characteristics are those software engineering capabilities, that it just seems like the hiring processes haven't really kept up with that.
I hired interns this year. I'm a big believer in interns because we must generate the next generation of engineers. We can't have a lost generation and a gap, or we're all doomed. The interview process, though, that I used for my interns this year was very different. I walked in there, and I'll share it here. It's no secret. We told our intern candidates when we selected the ones we'd like to talk to please use AI to write the code for their interview. That was, in fact, we expected them to do it. But we told them to use our SDK. We told them to implement, a feature and an experiment using our SDK. And then we had them walk through the code that the AI generated to be able to explain everything that was there. And we told them they were on the hook for the output. They had to be the responsible party. And they needed to show the value and that they understood what they were creating with the project. The second interview we did was a debugging interview where I wrote the code. I'm proud of it. I deliberately wrote bugs in there, or at least I'll pretend that I deliberately wrote bugs in there. Maybe it was intentional. Maybe it was just my code. But we put a series of different errors in there, and we had them find all the errors and debug by hand. And we thought that was a really important skill to show understanding in the code that was being produced and to be part of that resolution loop of how do we operationalize it. It was our cue for operational behavior of this went wrong in production. You showed up. Can you fix it? And I think those two skills were probably more important than can you turn a 3-paragraph essay into 100 lines of Python.
Yeah, I like that a lot. We were chatting yesterday too about how like our favorite interviews we've done too from the interviewee perspective is like, reviewing a pull request. Like it's amazing how much you can like show about what you know about software engineering and like your ability to communicate with other people, as well as, figure out how somebody's going to be able to work from something like that. So I like the debugging part of that. I like that. Sounds like you guys have already switched over to an AI era of interviews, which is nice.
Yeah, and the critical thinking piece. Like, do you take everything that the AI says as gospel and, copy paste into your code, or do you then ask those second, third order questions and, maybe ask it for an alternative, maybe ask it for 2 alternatives, ask it why it did something, those kinds of things.
Yeah, I think that's really important. The best that we can do right now, as of this point is a workflow. And I touched, I think, briefly on this a few moments ago, which is every project, every idea needs to start with a research phase. What do I have for assets that I can reuse? Right? This is still the DRI principle of don't repeat yourself, or DRY, sorry, the DRY principle. Don't repeat yourself. I can't spell without a whiteboard. No, don't repeat yourself, right? So we want to reuse what we have because that makes the code more efficient. And then it goes into the, get the background. So my agents will go out there and they check Confluence, which we use as our sort of wiki source of knowledge, all of our GitHubs, including our internal repos, which we have for our tools. What can it find? It looks at Slack for conversations that I might have. We're a G Suite shop, which makes it very easy for me to search through documents. So it searches all my documents. And so I get a good research plan of what do I know about the problem I'm being asked to solve. And then the second thing is let's formulate a plan based on that research, right? And so I've got a planning agent, and the planning agent goes out and it says, based on all the research, I'm going to plan this. And that becomes a very iterative conversation. That's where, I use my human judgment in the loop to plan out what it's going to look like. And then just go write the code. And of course, while it's writing the code, I still believe in test-driven development. And so I will have another parallel agent writing tests for that code, and those agents are communicating. Right. And so I get the testing agent to spit something out. And then once it's there, we have the PRs, the feature flags, the style. We have agents to review style. Does it match the existing code? Is it thematically correct? You don't want a jarring experience of the agent wrote this and it's completely different. And then, eventually there's the operational metrics. What are we looking for? Which are like the output criteria. So the tests run and as part of the build release pipeline, the CI pipeline, and we see what the results are and we go back and we pass that data back for iteration. I think that's kind of where the industry is headed. And, not everybody is there yet, but I think that's at least where we're going to be for a while. I'm sure the big frontier lab companies will come in and help sort of make this part of their own internal workflow versus us all cobbling it together. But, that seems to be what's working for me. I'm interested to hear your experiences. You're now at three different companies and with three different exposures.
Yeah, I mean, I definitely use AI on a daily basis. I find that like tuning my agents or tuning the skills, like that does still take time, And so there's times when I have to strike that balance of like, do I like how big is this problem? Like, what tool set do I need to build for this? Like, do I need to build an entire context, or do all I need is like, one markdown file and a couple PR references or something like that? So yeah, I don't know if I have like the full like agentic setup on everything, but yeah, it's definitely interesting to kind of hear how you work. And I would say like across what I've seen from different teams, people kind of have their own style. I wouldn't say it's fully consistent from what I've seen as far as how people use AI. It's a little more personal, but I feel like people are always sharing and we're always all learning from each other too. So it's still kind of in a state of development of like learning best practices from each other, building shared tooling, that kind of stuff.
Yeah, it's interesting to me that it seemed like for the first part of my career, there was always like methodologies to follow. Like we have Agile, whether we always followed Agile is a different question, but it was like typically the thing that we reached for to do software. And we had like typical design practices and things like that. But it does feel like we're all just kind of guessing and doing the best we can with now with AI tools. There's some books that have come out, but I think there is nothing like Agile for AI development that I've seen so far, or one standard that really just makes sense to adopt or to tweak on. And I think that's really the interesting part with organizations adopting AI or trying to scale up AI. And I do think that's interesting because, I mean, Brittany and I went to the Pragmatic Summit earlier this year, and there was a very interesting conversation about AI adoption and how in already efficient orgs or effective orgs, it tends to be really well received, well picked up. It does help with your productivity, but with less developed organizations or ones that already have problems in, it actually has the opposite effect. And so I find that so interesting that really the success of AI seems to develop on the already success of your company or your strategy. So I think it'll be interesting to see recommendations for how to scale AI, but it is very fascinating that it seems right now everyone has their own like agent or skills or whatnot that they're building, and that's where we're seeing most of the success.
Yeah, it kind of feels like the Wild West right now. Everybody's just kind of making it all up. And it's also coming at the same time where I feel like I'm personally doing a lot less pair programming than I did in the past because I can do so much more on my own. So I feel like maybe that's also part of it is, previously the idea was like, let's work together and, share knowledge one on one all the time. And that meant that, we were, really sharing a lot of those tools more widely, where now we have a little bit more time to like experiment with a thing and see what works, which I don't know, maybe that means like net more creativity in finding the way that things work. But yeah, I also found it really, I think that the AI adoption story is very interesting and seeing how organizations actually go about like, you know, rolling this out. That's one of the reasons why I wanted to change jobs recently is I was at GitHub for 4 years. That was through the entirety of AI existing. Like I want to see how this is working outside of just there. So yeah.
Love what you said too about sharing a bit. We do something we call AI Fridays. I can't take credit for it. It started before I joined the company, but it's truly been a boon for our adoption across the company where folks, I mean, it's a random share for all practical purposes where it's demoware, but a walkthrough on Fridays of, hey, this worked for me, or I discovered this new skill or tool or behavior, and here's how I'm using it to make my life better. And it's not just engineers. We held a hackathon internally. We call them moonshots a couple weeks ago here. And we're a small company. We're 600 people ish in that scale. So not huge. We had 75 submissions. Some teams did multiple submissions during the week, which we've never had. And we had folks from HR, from customer support, from sales, building apps and delivering them because they'd been enabled through the use of these tools to deliver code. And of the 75 projects, I'm going to say at least 50 of them are things that we could potentially ship with a little bit of cleanup. And the other 25 were either something really cool internally or make great demoware for a sales or customer visit to show them the capabilities of what we got. I was blown away by the creativity, by the productivity, by the usage, and the embrace that I've seen over the last 6 months from folks who probably, 6 months ago were digging their heels in. They're now like, wow, I am unlocked, unleashed, and, Leroy Jenkins into the fold.
It's very cool. Yeah, this kind of gets to my next question of speed and control. So awesome that there's so many submissions, and I don't know, it doesn't sound like you've mentioned this yet, but I know a lot of us get the message from our leadership that the goal is to ship fast. And in my mind, that kind of comes with some trade-offs, the speed and then the control and sometimes even the quality that comes when you're moving fast. So where do you kind of fall on that? And how do you think about balancing those two things? And is it necessary to slow down in some cases?
Great. It's actually a really great question. And from a LaunchDarkly point of view, we believe speed without control is a liability. It's a shipwreck waiting to happen. It's like giving a 16-year-old keys to a McLaren and hoping that they drive safely to the prom. It's not going to happen. I think we're all feeling that. Software has become deterministic now. Has gone from being deterministic to being probabilistic now. These models are random. And, there's a temperature coefficient on the model, which tells you exactly how random it is or not. We as people love that randomness because we anthropomorphize it and believe that they're human because they sound like they're human because of it. None of us probably went into software engineering because we like probability. We like the computer to do exactly what we told it to do all day long. It's the perfect wage slave for us, right? And we have to find a way to put it back on the rails. The best metaphor that somebody described this as in the company to me was, when you go bowling, have you ever seen those like kiddie parties where they pop the lane bumpers up on the side? And so you could throw a strike if you're good, but if you're like me when you bowl, you're going to need those bumpers on the edge to keep the ball going down the track so that you hit a few pins at the end of it. And I think our platform is all about that control. I ship something, I test the living daylights out of it. I started my career in software QA. I do everything I can to put the right thing out there in production. And lo and behold, we go from 4.8 to 5.0 on the model, and that we're using for an eval on the product to do something agentically. Everything changes. Or what worked today in a prompt doesn't work tomorrow in a prompt. You got to have a control plane out there that is managing your releases in production and watching for drift, because drift is now happening where it used to be perfect before. And I think that's the frustrating part for me. So yeah, we all want to go further, faster. We're all under more pressure than ever to deliver. Staff is getting cut. We all have an existential dread of, are we next? Like, I can't fix that, but I can say if I put some controls in there and some checks, I get the confidence that things are not going to go off the rails. I was, about 15 years ago, I was a CIO for a public company. And, I used to go to bed every night thinking I was one data breach from unemployment. And I think a lot of CIOs feel that. And it's a terrible way to live, by the way. Actually, it was not a job I particularly enjoyed, to be completely honest here. But I think, we all as software engineers have some of that same dread. Like, I'm one agentic misstep from, in a small company, torpedoing the company because I did something that blew out my budget for the year and now we don't have any money left. Or, in a major company, oh my God, we shipped something to the customers. Imagine, there was a well-known bug a few years ago that pretty much took down every Windows computer in the world because of a security tool. Like, imagine being that poor guy or who wrote that. You don't want to be that. And I think now when we don't have control because we're not watching every line of code, like, we're all feeling that dread, somewhere in our souls. And as engineers, we want to be right. Like, we're driven. There is a right answer to this problem. There's a set of compromises, but there is one right answer. And I think, without having the tooling in place to control that, to check it, to observe it continuously, like your speed becomes a liability, not an asset.
Part of this comes back to the question of ownership of like who owns it in production. And you talked about monitoring and drift, and the ultimate ownership of the system comes back to the humans. I kind of made a joke about the AI is not on call, but also the AI doesn't get a paycheck. Like, you're talking about this existential feeling, like it's my job ultimately to make sure that the system stays running and we deliver. So I'm the one ultimately responsible for whatever is executing.
Have you watched, Erika, the changes in the laws that the EU is pushing through?
No, I was curious if you could share more about that.
Yeah, it's super interesting, and we can all have opinions about regulations and whether they're good or bad, whether they're doing the right thing or not. But the facts are they're there, and the bottom line comes down to you fundamentally have a human responsible for it. There is liability, and it's no longer okay to say the agent or the algorithm did this. You have to ascribe a human to it. And that's a really weighty responsibility. And I think we're all searching for the right balance of tools that give us that confidence that they're doing the things with the best of intentions that I would do.
Yeah.
There's a lot more to it, whether you're a frontier model company, a manufacturer, like there's levels of depth to unpack here, but fundamentally they want to ascribe a human in the loop as responsible. And I think that's right. I can't fire an AI agent. I can't imprison an AI agent. Best I can do is pull the power cord and make it try to survive.
I also didn't major in computer science. I minored in it, but my mental model of computer science or software engineering was like, we're kind of professional cheaters. Like, we look up all the resources and stuff, combine it, and then like use that to solve a thing. And it's because, software has always been so shared and stuff. And so when I was going through school, it was Stack Overflow, like don't copy and paste from Stack Overflow. And I would always tell folks that I would mentor, I'm like, you know what? You're going to do it. Copy and paste from Stack Overflow, sure. But like, make sure you understand everything that you are putting down in your ID, like that you can personally attest to that, because that is what matters at the end of the day, is that you understand what you're doing. So whether or not you get it from somewhere else, like other people will have better ideas than you sometimes, but it's that you can personally explain and walk through everything that's going on there is so important. Even if you're able to ship faster, like, it's an important bottleneck to understand what you're shipping.
That's right. I took out a system once because of Stack Overflow. It wasn't intentional. It was an internal system, thank goodness. I had taken some code. It was doing a liveness check against another service on the network, and the Stack Overflow code never closed the socket. And leaking sockets in Windows kernel leaks a page of non-paged pool, or it did at the time. So that's memory that you can't swap out of the kernel. And so eventually the machines would just hit the blue screen of death and it would be out of non-paged pool. I couldn't figure this out for a while until I realized that it was me in user space doing something that should be fairly innocuous, open a socket, and never got cleaned up, and it just blew the machine out every night. Like, took me, a week probably to figure out it was just bad Stack Overflow code many years ago.
Yeah.
Well, this has been great. We are again coming up to time, so we always end with something fun. And Cameron, we understand that you are a licensed flight instructor. So tell us what all your various flight abilities are. What are all the planes that you can fly?
Well, I hold an airline transport pilot license with a type rating on the Boeing 737, so multi-engine land. But I also, I've been flying for more than 30 years. And it's always been my refuge for getting away from getting above it all is maybe the best metaphor I could say, pun intended. I started flying single engine Cessnas like everybody does. Along the way, I learned to fly seaplanes, including multi-engine seaplanes up in Alaska one summer. I own a seaplane. I've flown helicopters, so I've got a commercial helicopter license, commercial gyroplane license, which is a very funny thing if you've ever seen one. It's like a helicopter with a prop, so no tail rotor, but the prop pushes you, and the rotor blade is not driven. And then I've also flown gliders, which, as a powered pilot first, it's very scary the first time you go up in a glider and you suddenly have no engine. And then you realize, but I can fly like a bird and stay up for hours with no engine running. And it is the coolest feeling in the world. It's super freeing. And of course, skydiving, I've got a D license and 400 plus skydives over the years. I actually learned to skydive when I was living in Sweden overseas, and I learned in Swedish, which is an incredible way to test your language skills when you're about to jump 14,000 feet out of an airplane on your own.
Yeah, you probably want to understand the instructions there.
I mean, I thought I got it. I survived. So I absolutely love flying. It's a hobby. And the teaching part of it is because I genuinely enjoy teaching and I like to pass on my love of aviation and my knowledge to the next generation of pilots as well. And I've got former students that fly F-35s in the Air Force. I've got former students that are airline pilots, probably flying jets that you may or may not have ridden on. And I truly enjoy it. But software has been the career. Every time I've gone to, head off to an airline or considered heading off to an airline, I've gotten an interesting software job that just keeps me mentally engaged at the point where I'm like, you know what? I really enjoy this industry too.
Well, we're going to merge the two together.
Fair enough.
Experiences here. So each of us is going to pick an software engineering situation, and you get to translate it into a flight phase or some kind of like aviation experience that comes to mind. Okay, so there's no wrong answers here.
Oh, this will be fun.
We're learning from you about flying a bit through our lens of software engineering. So I'll go ahead and go first. So I'm gonna describe a one sentence description of a software engineering experience. Then you get to kind of translate it into what that means to you for flying. Okay. I will pick you ship something on a tight deadline and it just worked.
That is greasing the landing. You get it, you bring it in there, you barely feel those wheels touching down. It just kisses the pavement. Yeah, it's so satisfying. And it's mostly dumb luck.
That's great. I like that term. I'm going to use that next time I'm flying so I can be like, aha, I know flight things.
There you go.
All right, here's another one. You fixed a bug in production while pretending to be calm on a call with important stakeholders.
So there's a concept in the cockpit of the QRH, Quick Reference Handbook, and it's all the emergency procedures that after you've done the things by memory, you pull out when something goes wrong and you follow it step by step. And you did it without the passengers in the back noticing. So maybe you had an engine on fire, that warning light says your landing gear is coming down and you fixed it. They didn't know anything was wrong. They thought it was a normal flight.
It's fun talking about this because I think all of my flight knowledge comes from the rehearsal from Nathan Fielder. If you've seen that, if you haven't, really great.
Okay.
It's incredible. Second season specifically. So good. I will go. You gave confident advice in a meeting about a system you'd never actually look at.
You hung out on Reddit and you listened to a student pilot post some nugget of aviation knowledge and believed him.
No.
Student pilots will post confidently, I know everything about aviation. I'm like, come back in a couple thousand hours of flight time or just ask somebody who actually knows what they're doing.
Sounds like CS student or r/CS students too.
Right.
Yeah.
It's like, what do they say? I had a friend of mine, the guy who became a fighter pilot. He's like, yeah, you go in there and you have a second lieutenant who says, in my experience. And those three words just don't exist.
Yeah, that's valid. I think that's like a very persistent Reddit archetype.
Yeah.
Well, thank you for sharing a little bit of your aviation experience with us and just all of your thoughts about the world of the software development lifecycle and how you're thinking about all these things right now. That was really insightful and enjoyable. So where can folks find you after this if they're looking to hear more?
Well, I do a lot of media interviews and podcasts, and we're up on LaunchDarkly.com. I'm available on LinkedIn. Pretty easy to find. My name is pretty unique. You can easily get a hold of me through there or through the LaunchDarkly website.
Well, thank you, listeners, so much for tuning in to Overcommitted. If you like what you hear, please do follow, subscribe, or do whatever it is you like to do on the podcast app of your choice. Check us out on Blue Sky and share with your friends. Until next week, goodbye.